Have you ever launched your favorite cheat, only to see that it suddenly stops working, an error or crash? Today, we'll explain in detail why this happens. You'll learn how a game update can make your cheat non-functional, how the cheat update process works, and what most often breaks in it. Sit back and get comfortable. It will be detailed, even too much so. A cheat is not magic, but a software module that unofficially integrates into the game. It interacts with its logic, engine, and game data. That is, the cheat interacts with what was not intended to be interacted with from the outside. Essentially, a cheat connects to the game as an additional component to change its behavior to its advantage. However, due to this specificity, when the game updates and even small details change, the cheat cannot find its usual anchors and stops working. Developers constantly change the game code, sometimes for optimization and sometimes in preparation for future updates, and not all changes get into the update log, so cheats can break even where at first glance nothing has changed. How does a cheat detect the necessary parts of code, and why does it break after updates? Let's start with the most common reasons. In every game, there is a virtual table, similar to a cabinet with cells, where each cell is assigned a fixed number. When the game launches, each function, whether it's shooting or movement, is located at a predetermined index in this table. However, when updates are released, game developers optimize performance, add new mechanics, or fix bugs, which leads to changes in the table structure. What used to be in cell number 3 might move, and a cheat configured to access old indices might call the wrong function. Parallel to the change in addresses, code signatures also change, unique byte sequences that the cheat uses to find the necessary sections. Therefore, instead of looking for an exact match, patterns are used where some bytes remain fixed, while others can change with each game launch. This allows finding the right code even with dynamic changes. For example, imagine that in a hypothetical shooter, the damage calculation function had this signature before the update, where the question marks are variable bytes that can contain important information, such as the player rendering function address. The cheat, knowing this signature, scans memory, attracts necessary data from fixed and variable bytes, finds the needed function, and intercepts its operation, using it for its own purposes. For example, you can inject additional functionality and draw player outlines. After a game update, the function signature might change. For example, it used to look like, but now it looks like. Meanwhile, the variable bytes, marked as the question marks, remain flexible, while fixed bytes are explicitly set and require strict correspondence. Even if one fixed byte changes, a cheat looking for the old signature won't be able to detect the necessary code section. Thus, game updates affect both the location of data and memory, and the fingerprints of code by which the cheat looks for intervention points. Even the slightest change, whether address offsets or changes in fixed bytes in the signature, disables the cheat, forcing developers to constantly update their solutions. In the above-mentioned case, game developers shuffled the cells around and changed their labeling, but it also happens that developers can change the contents of these cells. To simplify, the cheat thinks that the shooting function is in the third cell, but in reality, reloading is now there. The cheat tries to shoot, but instead, it reloads. But let's examine this in more detail. Each item in the game has an ordered list of possible actions. During compilation, an agreement is created that determines which functions can be implemented by a specific object, and what will be located in the table under predetermined indices. This information is baked into the game's binary file, and any code using this table follows the established order. The cheat, like the game, uses the function table to search for and call the necessary code. However, after an update, developers may not just change the order of functions, but also change their logic. For example, instead of simply replacing numbers in the table, they might add additional conditions or even combine several functions into one. As a result, a cheat that continues to use the old scheme either calls the wrong function or cannot process the new conditions. This leads to it working incorrectly or completely ceasing to function, as it no longer corresponds to the changed structure of the game code. We've figured out the reasons. Now let's move on to how developers update their cheat. It all starts with the simplest thing. The cheat developer receives a notification that the game's been updated. There are two possible scenarios here. In the first case, if the update's minor, the cheat's auto-updater will work. a special utility developed exclusively to take pattern searching out of the cheat. It automatically finds new signatures, updates them, and uploads the cheat update to the server. This speeds up cheat injection, increases security, and makes the update process more flexible. Previously, in many cheats, pattern searching was done during initialization, which significantly slowed down the launch. In this case, automatic cheat updating usually takes no more than 10 minutes. If the game update is global in nature, then the auto-updater won't be able to handle it. In such a case, after 10 minutes, the developer will either check the cheat in the game himself, or the good audience will notify him that the cheat's not working. This means that the game update is not simple, and the cheat needs to be fixed manually. Then, everything follows a worked-out scenario. The problem needs to be noticed. These could be crashes, errors, or malfunctions in individual functions, accompanied by messages and logs indicating that necessary data couldn't be found in the game's memory. In addition, messages come from beta testers, users, or even the developer himself, who noticed a discrepancy in the cheat's behavior after the update. Next, the cause needs to be found. Two main approaches are used for this. The coder launches the cheat and uses a debugger to track how key parts of the code are executed. He compares the obtained data with the expected and looks for discrepancies. If something's changed, he studies the necessary section of the game code and looks for a new way to get the data. The old and new executable game files are compared to immediately find changes. Which parts of the code were added, removed, or changed? Sometimes this analysis is supplemented by manual verification if a deeper understanding of the game's change logic is needed. After the cause is identified, cheat developers make necessary changes. The cheat update process essentially repeats its initial development, but in a simplified form. All discrepancies related to the game code are replaced with current ones. Sometimes it's enough to update signatures or indices by which the cheat searches for code sections. And in other cases, entire modules have to be rewritten to ensure correct interaction with the new version of the game. This process can be both quite fast and prolonged. It all depends on how many things the game developers changed in the update. Although an experienced cheat developer, well acquainted with the mechanics and direction of game development, can try to predict future changes, the unpredictability of patches often forces him to spend weeks adapting his tool. That's all. Subscribe to our channel so you don't miss even more interesting videos. This was the Never Lose team. See you in the next videos.